So, if I wanted to make something non-beyond, I think it works with regular AR. Is it visual?
Okay. Ladies and gentlemen, let's go ahead and get to it. All right. Congratulations. You made it. You finished homework 5. Well done. How are you feeling? How tired are you? A little bit? Yeah. Again, homework 5 will never be harder than it was this semester. I appreciate you overcoming the friction, dealing with the fact that there's some bugs in the spec. There are some bugs in the guides. The tutorial video was not uploaded quite in time. And I appreciate you for getting through that, okay? And if difficulties arise in other assignments, we'll be watching, okay? We'll be taking a look, and we will be responsive with extensions and stuff like that if it looks like everyone needs them in general, okay? So don't worry too much. Simply do the best you can in this course. The grades will work themselves up, I promise, okay? Put in a good effort, do a good job as best you can, and we'll be all right. So, because of the delay, we are not launching the new assignment on Monday. We are launching it today, okay? Homework 6 has been available for a couple days. How many of you have launched or have started homework 6? How many of you have looked at it? Okay, a few of you? Awesome. Homework 6 is going to have a pretty different feel to homework 5. It is a homework that is going to take your engine and make it feel a lot more like a typical, more traditional 2D modern game. But the difficulty, it's not going to come from linking. It's not going to come from building or including the right headers. It is going to come from the increased complexity of the gameplay logic. Okay? And in particular, we think it's going to come from the collision logic and the collision algorithm you're going to need. On top of that, this is a week that does have some performance requirements. Okay? A reminder, you do not need to get all those performance test cases to have a fantastic grade in this course. Okay? They're not going to be easy this week. All right? And there is some thinking you'll have to do, and there's some discussion we're going to have. We'll have it today, about how you can kind of deal with collisions in a much more efficient, much more thoughtful way than just scanning through the entire list of actors to compare AABB, collision checking with, okay? And so look forward to that. If you enjoy performance testing, iterating on your performance, I think you'll enjoy this week's work, and we'll get to that very soon, okay? You can see we're halfway through the week, not quite halfway. You've got about 5 days remaining on language host on continuous worlds, homework 6. But in reality, you've got a bit more time than that. It's going to be due Tuesday at 4:30, okay? All right. Currently, the Mac autograder is down, if anyone was curious, for homework 6, okay? So I'm going to fix that up tonight before I go home. So you will be able to submit on Mac homework 6 very soon. Not right now, though. This has been sending me an error email every 2 minutes since about 1:30 today. Okay, my inbox has been annihilated, and the good news is it stops sending me like the rumble and sound notifications after about 100 of them. So it's no longer driving me mad. Anyway, let's go ahead and keep going. Today we've got a game engine of the day for you, and just to make sure I'm streaming, hello to everyone on the stream. We have a fairly well-known game engine. Who has heard of it? It is RenPy. Pi. Right there in the name, this is a Python-based game engine However, it is not necessarily a version of Python you're going to be super familiar with. I think they're doing some funky stuff to this Python. You'll see it in just a little bit. There's a lot of syntax in there that I've never really seen before. But this is a very highly opinionated game engine for the visual novel genre, in the same way that the RPG Maker engine is very, very opinionated on what it thinks an RPG needs to look like. And it's going to give you a lot of great structure and technology and features to get you started on that path. So too will RenPy give you a lot of great functionality and templates to start out, but of course in the visual novel genre. All right. Initial release was 2004. A lot of stuff happened in 2004. I think we've had several engines release around 2004, including Frostbite. It was created by Tom Rothamel. I know almost nothing about this person other than their nickname. I cannot find any history on this person. I'm not sure why they made RenPy. I assume they are a big fan of the visual novel genre. And that's all I could really find. Maybe next semester I'll have more for you. There's a website dedicated to it. And one of the cooler things I saw on this website is that they have sponsors. And the top sponsor is a company that's actually published some local games before here in Ann Arbor and Ypsilanti, Radalaika Games. I've talked to them a couple times. What's really clever is they got a sponsorship. They gave enough money to RenPy, probably every month or every year, to get the top banner spot. And the banner, they literally put an ad in it, right? Like, hey, by the way, we'll port and publish your visual novel to consoles, right? What a clever business tactic. You like to think, oh, these teams, right, they really appreciate the work of RenPy. They're just going to donate out of the goodness of their heart. No, this is coming straight from the marketing budget, guaranteed, okay? Probably get a tax write-off on it, too. So very clever, shrewd business right here. And, of course, it's like the first thing you see. You don't know... you don't think about anyone else if you want to get your stuff published, okay? Anyway, let's keep going here. It is famous. By far the most famous game to come out of RenPy is a game by the name of Doki Doki Literature Club. This is a game about a literature club, and that is the only thing that you need to know about that game, okay? And that is it. You can see a screenshot here. It is an anime art style. And it's a very charming game, and I'm sure that's why it's so famous. Anyway, if you know about Doki Doki Literature Club, you know this game goes off the rails in a very hard way pretty quickly. And a lot of strange things start to happen in this game, and that fact should clue you in to just how much expressiveness and flexibility you actually have under the hood, okay? So RenPy might be very opinionated, but like RPG Maker, if you really want to, you can get in there. You can start really messing with things if you want to. Visual novels only for the most part here. You can do other kinds of games, so it's a big pain. There's a very big market for these kind of games. How many of you play visual novel games pretty regularly? Anyone? Okay, no one in here really. I don't really play them that much. I played the KFC game. That was pretty good. I liked it. It was free, though. This is a huge market, absolutely massive, okay? Compared to what you might be thinking about. This is a game called Long Live the Queen. Have you heard of it? No? You have? Okay. I had not heard of it, okay? Not a super well-known game in this group maybe, but look at these numbers, 5,619 very positive reviews. At $10 a pop, that is some serious coin, okay? That's a solid market. If you can continue to make games hit that, you're going to be just fine as a business. So you can make some good stuff, right? You can get some good attention and make a living making these kind of games. In fact, let me see here. MichiganGameStudios.com. We have a phenomenal studio called Nochi. Anyone heard of Nochi? Where are they? Where's Nochi? Here they are. Nochi is run by Professor Natalie Fang in the new professor in School of Information. and she builds these kinds of games. Her entire company is based around putting out a game like this roughly every quarter. So I'm not sure how she manages to do this with her busy teaching schedule, but she does, and she hires a lot of my students, so keep an eye out, okay? Anyway, pretty impressive stuff, and if you haven't thought about it, you can make a business in that genre. It is open source. RenPy, you can clone it. You can check it out if you want to, get a feel for how it works, poke around and prod around. It makes heavy use of Python as a scripting language. I'm going to show you that in a sec. There are plugins available for embedding RenPy into other engines. And one of the reasons you might do that is if you want to, for instance, port to console a little bit easier. Maybe you don't go through Radalaika and you want to try and do it yourself. Getting it working inside of Unity unlocks the entire Unity ecosystem, and it also gives you the functionality of RenPy, okay? It provides a lot of great features out of the box, and I have a demo ready for you. Here's what you get when you download RenPy. You get this, okay? A folder that says RenPy 8.2 SDK, and it's just a folder full of stuff, okay? You can kind of think of these as like the resource folders that you're slowly building out. It's just getting more and more full of stuff. Pretty soon, we might not even know what any of it means anymore. Anyway, we've got this application we could run called RenPy. Got a few other folders called RenPy, or things called RenPy too. It's a little bit strange. And hopefully it's going to run here. I've been having hard disk problems on this laptop, so hopefully it holds out for us. We can see that there are currently two projects. There's a tutorial, and then there's a kind of a sample game called The Question. And we can kind of launch these projects, either of them, from here using this button. We can also open various games. So we can open the images folder. We can edit scripts and stuff. We can build for different platforms. We can extract dialogue to a different form. This is basically a web front end because RenPy is not an integrated engine like Unity or anything else. This is kind of similar to Source, right? We saw Source Engine on Monday. It's an engine that doesn't have a fully featured, polished, integrated editor with everything just packed in, but it does have a little menu that can kind of get you to the different tools and get you moving a little bit faster. Okay? If you look right here, the tutorial, The Question, right? These two game titles are literally right here. The Question right here, and tutorial right here. A game, just like with our engines, a game in RenPy is literally just a folder. Okay, it's a folder full of stuff. And if it's got the right stuff, you got yourself a game. Okay? Anyway, let's go ahead and launch this right here so you can get a feel for what RenPy is like. It even gives you quick tips. Have you backed up your projects lately? Right? Adorable. Okay, The Question, RenPy 7 Plus Edition, some nice art. This is like the stock start menu that you just get for free, okay? And it all works, looks pretty good. Okay, got some stock music here. If you look at the bottom, we've got additional features like history or skip. You can save at any time. You got preferences here. You get all this for free in the engine. It says, it's only when I hear the sounds of shuffling feet and supplies being put away that I realize the lecture is finished. Okay? Click. Professor Eileen's lectures are usually interesting, but today I just couldn't concentrate on it. I've had a lot of other questions on my mind, thoughts that culminate in one question. It's a question that I've been meaning to ask a certain someone. And that question is, should I take 494 or 440 next semester? And that's a really good question, okay? I just don't know. Maybe I will take both. Anyway, we get outside, we get a scene transition there, so it has facilities for this too, okay? We've got facilities in this engine for bringing characters up, right? For getting characters interacting with the player, right? I've known Sylvie since we were kids. She's got a big heart. She's always been a good friend to me. But recently I felt that I wanted something more than just talking, more than just walking home together when our classes end. Should we ask her right away or ask her later? Okay? So we have facilities for dialogue choices here too. And you can branch your story, your script based on that. Now, we don't have time to go through this full thing, so we're going to ask her later. Bad move, okay? I can't get up the nerve to ask right now with a gulp. I decided to ask later. And that is, but I'm an indecisive person. I couldn't ask her that day. I end up never being able to ask her. And I guess I'll never know the answer to my question. That's a bad ending, okay? So there you go. We're back to the title screen, and that's how it be. When we look into the question folder, the folder that actually represents all of our game's assets, code, images, logic, all that, we're going to find a bunch of icons, okay? We're going to find, I think, some config files in here, similar to your game.config, your rendering.config. Let's go into game here. There are a bunch of Python files, RPY. They're not quite Python files, are they? Right? They're RenPy Python files. And one really big one is script right here. Okay, so this script.renpy is basically what I edited last night to change the story. Oh no, my hard drive, rest in peace. So Windows Explorer, like, shouldn't ever do this, right? Like, this is a program that was made by Microsoft, the operating system developers, and like, they use this, and everyone uses this constantly, so it should be relatively bug-free. And the only thing that could be going wrong here probably is some sort of hardware-related issue. So, yeah, Windows Explorer is getting restarted. Rest in peace. Maybe we'll be able to show it to you. Maybe we can't. Maybe you'll have to imagine it. But basically, oh no. Uh-oh. Okay, this is getting real spooky. We do have another part of the lecture we have to get to. So if we have to abandon the desktop here, the file system, we will. But basically, when you open up that script.rpy file, you'll find syntax that looks very similar to Python, but has some new keywords introduced. Right? In particular, you no longer see a bunch of def and then function name, right? To define a function, you, instead of seeing def, you see things like scene, okay? And that can change kind of what that function does and how it gets packaged up and interpreted. I think, does anyone know for sure? I didn't have a ton of time to look into this. I think there's probably some sort of custom RenPy processor that takes these files and generates actual Python from them before running it. Anyway, we might be cooked here. This is a very new laptop, but you should know that I got it on sale about 60% off, and now I'm beginning to regret that. Yeah, I don't know. It's just not a. I can't even see the Windows Explorer in the taskbar, so this could be a reset. Thankfully, we don't have that much to do on the desktop today. Anyway, RenPy, a really, really cool engine. There are a lot of people out there who have interesting stories to tell. And this is one of those tools that can get you writing new code. Well, not writing code, but creating new stories, writing new dialogue, right? Getting your characters in there very quickly, okay? Without a whole lot of programming knowledge needed. And I think that's a really cool thing, right? Bring game dev to more and more people, more and more markets, and all that good stuff. So, all right, we're approaching 4 weeks into our engine production. We have about 6 weeks remaining, okay? And I'm curious, how do you feel about your engine's hygiene? How do you feel about your code base, your structure, right? Your style? Is it starting to get a little bit sus? Is it starting to feel a little bit brittle? I'm curious. How do you feel about it? Kinda, sorta. Okay, explain. Elaborate.
Well, for homework 5, I just threw shit together. So homework 6, I know my formula, and I just gotta do that. Because in homework 5, I was like, is this the structure? Is it not? So it was like testing it also like with the deadline. So I'm like, well.
Yeah. Yeah, absolutely. Absolutely. Yes, bro?
I don't like the way that I've like split functionality between my managers and the things they manage. I feel like that could be like organized better.
Sure.
There's some things the managed objects do that the manager should do, and vice versa.
Got you. Okay. So consistency is huge, right? A lot of people will say, well, no, high quality coding style is OOP, object-oriented programming everywhere. But a lot of teams would say, you know what, we actually prefer the kind of C-style programming, a little bit older school, a little bit more in the vein of SDL. And in my experience, the most important thing there might be just consistency. You're trying to choose a philosophy and stick to it as much as you can, and not messing around too much, not crossing the streams too much. But I think the question of what does good code look like is kind of a hard one, right? It is, in many cases, a bit subjective. And I think over time, you'll get a feel for it. And I think you'll come to figure out what your idea, your unique idea of good coding style looks like. Hopefully, it is largely compatible with what your peers and team members also think is reasonably good coding style. And more than anything, I hope you remain flexible and open to adapting to whatever team you jump on, what they favor in their coding style. In my opinion, I found that I really like to focus on the concept of dry as much as I can in my coding. So I might not have a ton of classes. Maybe I don't use inheritance as much as I could. But in general, if I'm copying and pasting anything, that is a instant feeling of doom, okay, that crawls in. The idea that, oh no, I've got repetitive logic here. I'm going to need to update this, but I'm going to forget about the other locations I pasted that logic, and now we're in big trouble, right? So maintenance sites and adhering to dry as much as possible. If it's doing that, there's a good chance I'm going to feel it's probably decent coding style. Try and keep things encapsulated. Expose only the things that you need to other classes. Use your private, right? Your private access specifier. And you'll probably be okay. I would also say don't go too crazy, right? You don't have to introduce 1,000 different classes. You don't have to use tons of inheritance everywhere or implement your own composition like Unity, at least not yet. On Homework 7, you will need to do that. And don't fret too much, okay? Don't fret too much. There are lots of different philosophies on what good coding style is, and you'll naturally get a feel for what you like and what makes sense and what leads to better, more performant dev time as you continue to develop, okay? And if you want any advice or feedback, you can always ask your staff, and we'll lend you our perspective as best as we can, okay? Keep in mind, though, that all of your staff are extremely early in their careers, and our opinions on what good coding style mean is almost certainly going to change. It could change even this year, okay? So keep that in mind. All right. With your engine taking on a bunch of different dependencies now, I mean, you spent half the homework probably linking and trying to get things working with your code. That's something that's actually a very big deal. At some big teams and corporations, you can't just add something to your project. You need to send it through legal. You need to get your superiors to sign off on it. And in many cases, that comes down to a license, okay? You can't just typically grab something that someone else made and just take it, okay? Like, if that's a physical item, that's kind of theft. And if that is kind of original IP, right? If that's a bit more ephemeral, there are often copyright issues to consider and stuff like that. An example, let's see here. An example, did you know that Unity uses SDL under the hood? It absolutely does. You can actually, no one ever goes looking for this, but you can actually go up to help in Unity's editor, go to software licenses, and that's not talking about the license you got from Unity. That is the licenses that Unity acquired so that they could deliver Unity as it currently is. When you click on that, you're going to get this text file right here, which, oh my God, look at that. Oh, look at that bar. Okay, that is a big one. Okay, you can find they're using all sorts of stuff. They're using Paco library. Can you believe it? Okay, does anyone know what that is? I don't either. You can Google it if you want to. L4Z, some compression stuff. Small V, no idea. CUDA, DirectX text. Okay, let's search for SDL. We've got a bunch of libraries that use SDL, and then we have SDL. Okay, SDL2, Sam Lantinga, and we have, it's under the zlib license. Does anyone know what the zlib license is? The zlib license, you should probably, if you're using a dependency, you should probably figure out what the license is that you're using the stuff under, because some of them can be kind of scary. Here's the entire zlib license. It's very short, and that usually means one thing. It means they're probably just trying to give this stuff to you for free, but they want to make sure you're not going to sue them. Okay? So this software is provided as is without any express or implied warranty. So you're getting this stuff without any warranty. So if it blows up your computer, you can't do anything. Okay? Don't attack us. In no event will the authors be held liable for any damages arising from the use of the software. Permission is granted to anyone using the software for any purpose, including commercial applications, and that's a big one. You'll find a lot of licenses out there that are like, hey, you can use this for anything, as long as you're not making money, okay? And for businesses, this is a big problem. You have to abandon the software if you're a business wanting to use it in a commercial capacity. Or sometimes you can contact the authors, say, hey, we're a business, we want to use this software, please. And they'll say, no problem. Just pay us 10 grand a year. We'll give you a license that is not that license, and you can now use it. Right? And to alter it and redistribute it freely, subject to the following restrictions. The origin of the software cannot be misrepresented. In other words, you can't say you wrote the software, okay? And that's just kind of, I guess, a respect thing. If you use this software in a product, an acknowledgement in the product documentation would be appreciated, but it's not required, okay? I wonder what lawyers think of this. Do lawyers typically want to put this in a contract? It's like, this is just kind of a nothing sentence. It's just expressing please, but not a requirement. Anyway, you should do it. It's nice, very kind of you to do that. Altered source versions must be plainly marked as such and must not be misrepresented by the original software. This is basically saying if you mess around with this software and then it's all buggy and crappy now, you can't pretend we made that buggy version. No, it was you, okay? This notice may not be removed or altered from any source distribution. So they just want to kind of keep the license in the source code somewhere with the source code. Okay? That's it. All right. The zlib license is very permissive, very nice. I imagine legal at most companies would not care if you use the software. Has anyone heard of the GPL? Okay, what's spooky? You say GPL and everyone runs away. Okay? What's scary about the GPL for certain businesses? Yes?
If you use it and you don't, so if it's GPL and you use it, you must publish your source code. And if it's LGPL and you static link it, then you also must publish your source code.
Yes. So GPL, you can use this phenomenal software, but if you do, you have to publish any source code you used it with. And that is going to be a scary thing, right? So if you're Sony and you want to write the operating system for the PlayStation 4, the PlayStation 5, and you want to use like Unix, you want to use a Linux, okay? Linux is GPL, I think, right?
Kernel is not, but most distros are.
So Sony doesn't want to have to publish all their customizations and the source code and all of that stuff. They're spooked by it. So what do? Does anyone know what they use on their machines? They don't use Linux, but they use something vaguely similar, but with a nicer license. They use a thing called BSD. Has anyone heard of that? Which has a much more permissive license than Linux does. So anyway, this stuff is pretty important. I know it's not a very technical thing, but this is going to be on the quiz, okay? Not in a big way, but you should be aware of the licenses that your software is using. Okay, so keep that in mind. Next quiz. Here are some of the bigger topics that'll be there on Monday. Now, I'm going to try and make this a bit easier than the last one, so don't worry too much. But you're going to want to review the lecture documents, the previous few lecture documents, quickly run through the slides. And also, if you suspect that something is going to show up on the quiz, have it ready. Have it open in a tab before the quiz starts, okay? So you can review through it quickly, and maybe you can find the answer quickly. That's going to be helpful, okay? So topics related to SDL, okay? Which function calls are involved, okay? How does SDL work? How does the event queue work, okay? This should be pretty familiar by now. If you've gotten through homework 5, I wouldn't be too concerned. The input manager, which we talked about on Monday, this is going to become kind of a bigger topic on homework 6. So you'll get maybe a little bit of experience with that. And on homework 7, you're definitely going to be implementing your own input manager if you haven't yet. AABB collision calculations. Okay, this is something we're going to talk about today. It is going to be important on homework 6. The 2D transformation matrix. Not something that most of us will use on homework 5 or 6, but you can use it. And I guarantee you're going to see that thing again. It's going to keep popping up. If you continue to create an engine, if you make it 3D, if you take a 3D graphics course, you're going to need to know about that matrix, okay, and how to use it. And so review those slides for sure. And essentially any topic from the last quiz, since the last quiz could make an appearance. We're not trying to slip something by you, okay, or fool you. That's not our point. I don't get paid more if we've got points taken away. In fact, it's kind of the opposite. If too many people fail a course, you got some hard questions to answer. But anyway, just be sure to look through the topics we've touched upon, and you'll probably not get blindsided by anything. Okay? I'll try and make things a little bit easier, a little bit more straightforward than the last one. No guarantees, but that's what we're going to try. Okay? Remember, your worst grade on your quiz will be dropped. So you can rest easy, I suppose, as long as you haven't skipped one yet, because we've definitely seen some skips. So homework 6 is here. You can submit to it right now, just not on OSX, apparently. So what is it all about? Well, we are escaping the grid world, okay? The grid is a phenomenal place to be. It's a classic, beloved place to be. People are still making games that are heavily based on the grid, but that is a minority of games, and we need to expand beyond that. If you think about it, and I'll go into this in a sec, if you think about it, grid worlds are a subset of more continuous worlds, right? You can emulate a grid world in an engine that can support continuous movement and continuous, right, locations, but the opposite is not true, okay? And so let's talk a little bit about grids, okay? They are so nice. There are many benefits, right? There are so many benefits, in fact, that many modern games, luxurious modern games with big budgets like Civilization, still use grids. And how many of you have played a board game in the last week or two, okay? Right? It's still popular, all right? This is a tried and true formula. It's not going anywhere. One of the big wins from grid approaches is that it really helps with visual organization and clarity. When you have a grid, you are kind of limiting, usually, the number of actors and the number of entities that can be in a spot. Now, in our engine, that's not necessarily true, but in many circumstances it is. There's often a focus on design, right? You don't have to worry about positioning like in a very granular way. Positioning as a concept becomes a little bit chunkier, a little bit more clear, and something you can really focus on a bit more without getting buried in the details and off by one errors and stuff like that. You can think of it, right? The game of chess. It is a very discrete game. It doesn't matter if the pawn is slightly off the grid or not. It's just on the grid, and you can really reason about spacing and distance and movement a lot easier this way, okay? It's also very computationally convenient, all right? Physics systems, collision detection is a field so big and so important that we could have an entire class dedicated to building our own physics engine. It would be a brutal class, probably harder than this class, and we would need to restrict it to those who have completed a number of physics courses already before getting into it. And so it's really nice to have a grid, right? So on a grid, like how can you just kind of like decide, how do you know if you're going to collide with something? do you even need to take the shape of the object into account? It's like, no, right? You're either at a location or you're not. You can't be between locations. You can't usually take up more than one location. The question of collisions is just very, very easy, very nice. But there are many, many problems. It's very unrealistic, okay? Grids are simply not the way that we move through space, okay? And it can break some immersion that way. You get grids into your game, it's going to feel gamey. And I love that, right? I love that feeling that I'm playing a video game, something that's not quite real. But in many cases, you don't want that, all right? There is kind of reduced entropy, right? Grids kind of struggle at creating crazy scenarios. They can do it. I believe, isn't Dwarf Fortress technically grid-based, or is that continuous and then they render it as a grid?
It's an actual grid.
It's an actual grid. Okay, right? But if you look at a physics engine for just a moment and you see objects flying in every direction because an explosion occurred, right? There's energy there. There's excitement, right? There's charisma in that continuous world, that realistic reaction that just ain't going to be there for most grid situations. You can't imagine something crazy like GTA 5 Online, on a grid. It's just very hard to imagine that madness working out, okay? The physics can be very computationally easy to understand, but it's also kind of boring, all right? And everything tends to look very stiff, okay? You look at the GIF back here, and it's like, it's not that convincing, is it, right? It looks like you're moving a chess piece around, okay? And so, right, we want continuous worlds instead. And what is that going to take? Well, continuous worlds are kind of probably what most people think about when they think about video games, okay? Super Mario, right? Running and jumping with this nice velocity, the sense of motion and weight and momentum, right? That's just not going to feel the same on a grid, okay? Modern games, right? Very smooth, three-dimensional movement, right? Realistic and very, very nice. That's not going to happen on a grid, okay? And so we might have to think about giving up on grids, but there's actually an interesting middle ground. And this is actually what I really like, where you consider grids to be something of an interface, but you can represent your units and your characters and objects in between those spaces, okay? In this example, you've seen it a few times. Basically, you can order units to go to certain grid tiles, but they do navigate between them. There's a continuous world they can exist in between those grid points. This does a few nice things. It looks pretty good, right? It gets you some of that entropy back and some of that charisma back in immersion, but also simplifies your interface, okay? You can click on certain locations. You don't have to worry about slightly misclicking. No, you're going to hit the cell that you want, okay? Every time. It's a continuous world, but it enforces a grid, and that can be a very popular approach, okay? So one way to think of this is that continuous worlds are strictly more expressive than grid worlds because you can basically emulate a grid world within the continuous world. The opposite is not true, okay? Some tips on this assignment, okay? This is going to be probably a somewhat tough week, but for different reasons than the previous week, okay? Performance this week is going to be a big deal. And again, if you don't have the time for it, then don't feel bad about not getting all those performance points, okay? You're not going to need them all. You don't need them all to get a great grade in this course, even on this assignment. And the performance is not necessarily going to hamstring you for future homeworks if you don't quite get it going fully this week, okay? So keep that in mind, and don't let it stress you out or make you anxious if you can't quite get them all. I don't even think Nikhil was going through, and it took you a while to get most of them, right?
The first try, I couldn't get all of them.
Yeah.
It wasn't until you told me the optimizations you did that I was able to get them.
Got you. I'm gonna tell you a lot of the optimizations I did. So hopefully you'll be in okay shape. The integration test can be pretty tough. Okay. We're gonna do 100,000 actors at once. This is actually wrong. We're going to 1 million. Okay. We're definitely going to 1 million. Don't we go to 1 million? I can't remember.
So we have one test case that has 1 million actors rendered.
Oh, but no collisions on that one. Okay, hundreds of thousands of actors with collisions, millions without them. Okay, By the way, how many of you in your homework 5s are rendering an actor no matter what? Like there's an actor with a view image, you're rendering that thing. Okay? How many of you are like, that actor is way over there, I'm not rendering that? Okay, all right. You're going to need to do some of those things. You're going to have to think about which actors do I actually care about right now, which actors need to have collisions checked on them, and which ones don't, okay? There's a chance you can run into those horrible, scary, off by 1 pixel issues, okay? Now, I haven't seen any of those in quite a while. I think we had like 1 student who had a few on homework 5, and that was using like the absolute rounding function instead of STD absolute. I didn't know that was going to cause a problem. But we've got, I think the autograder's checking for that now, hopefully. You're going to want to be careful of rounding. The spec, I think, gives you some details about when you should round and when you shouldn't. You're going to want to be careful about the current frame number. So the current frame number is actually held within helper.h. Did you know that? The helper will count your frame for you, and you can get that number from it easily. I think there's a get current frame function you can call. It's something like that. You can look in the actual source file to see what it's going to be. But use that, okay? Make use of that. That will advance every time you call SDL or helper : SDL render present 498, okay? And so use that. But there are some nice things, okay? No new dependencies. And this is probably going to be, hopefully, some of the more interesting work that you've done yet, okay? Especially if you do like performance topics and you really like doing little experiments to see if you can squeeze a little bit more performance out of every frame. I really like that kind of work. I just wish I was better at it. And so, if you like that work too, hopefully you'll enjoy, and the time will go by quickly, okay? Remember the chain of help, all right? Make sure you ask for help early. If you ask for help on the final day, it's going to be hard to help you, okay, in time. So please get out, use you got a lot of office hours in this course. Please make use of them if you can. And hopefully you'll have a good assignment, okay? So, does anyone have any questions on homework 6? Let's take a look really briefly at the spec. Where's that spec at? Where is it at? Here it is. Oh, there's a really short reading on juice, okay? A lot of what we're doing, moving from a grid world to a continuous world, might be said to be juicy, okay? Adding juice, adding feedback, adding charm and personality to our game. And so if you want to know why that's important and get a feel for that concept a little bit better, you can watch these pretty good videos here, okay? All right. Let's go ahead and look at the assignment spec. If there's anything we want to show you. Let's see here. Yep, no new dependencies. That's pretty fun. You're going to implement basic camera zoom, okay? All these features are going to become very nice when we get to homework 7, and you need to provide your user, your game designer, with the ability to control camera zoom through Lua. Well, you're going to already have it implemented. It's not going to be that bad, okay? You're going to do continuous movement. So instead of moving a full unit, you're now going to move a fraction of a unit, a scene unit, and you're going to check if there's something in the way. And if something's not in the way, you've got a collision, you're going to reverse your direction if you're an NPC, stuff like that. We're going to do camera easing. And if you don't know what this is, you've got a little video of it here. Let's see here. So you see when the character moves, the camera kind of smoothly follows the character around. This is something that's very common in games and just creates kind of a more polished feel to the entire experience. So that's kind of cool. You're going to do some basic animation. Let's see if we got another video here. Okay, so you'll have your character actually look in the direction that you're moving, right? Imagine that. You'll do collision stuff. My impression is that Test Suite 4 might be one of the hardest in the assignment. Collisions are a little bit gnarly. Okay, we got some test cases that are dedicated just to helping you understand what we're looking for as far as collision detection goes and how to react to collisions. And hopefully that won't be too bad. We got more sound effects going on. we've got then our integration and performance tests on test suite 6, okay? So only 6 test suites. That doesn't sound like a ton. But yeah, hopefully it won't be too bad of an assignment, okay? For homework 7, launching in a week or so, you'll have 2 weeks, okay? And spring break will be right in the middle of that. And so you won't have anything to work on during spring break. You'll be free of this course unless you're way behind. And then, maybe you use spring break, though I hope you don't. I hope you don't have to. Anyway, okay. Any questions on homework 6? All right, cool. Let's keep going. All right. Let's talk a little bit about collisions. All right. So collisions are a little bit more interesting in homework 6. And if I had to say there's any big challenge or big new idea in homework 6, it's probably going to be how do we handle collisions now that we're no longer in this wonderful, friendly grid world that makes collisions kind of trivial, okay? So we're going to have to get from the grid world we're used to what we see on the right, which is kind of a much more interesting, organic style of collision detection. A quick note on why grids are nice. We kind of talked about this, right? But when we go to ask ourselves, can our goose hero move east, right? This is extremely easy to answer. It's very fast to answer, okay? If you introduce a data structure, then it's no big deal. By the way, a quick thing to point out here, and this is going to become another recurring theme of the course, and probably in your software development in general. When you have just a list of actors, that's kind of the first data structure you start with in this engine, isn't it? You've got a basic list of actors. That's all you got, a vector of actors. That's what we give you in homework 3. But it's not good enough. It's not fast enough, right? You need another way to think about these actors, so what do? What did you do to accelerate your collision detection? You still have that initial vector of actors, right? But you add something more. You add what? You add a map, right? You add kind of a spatial hashing, unordered map that allows you to what?
Better store and get those corresponding points and number operation.
Yeah, basically it allows you to say, is there something blocking me on this tile? It allows you to say that in O of 1 time, okay? And so, basically, what happened was this. You had some data, you had a certain query, a certain question you wanted to answer it fast. But with that one vector that you started with, the best you can do with that one vector is iterate through it, linear time check, right? That stinks. We can go from O of n to O of 1 by introducing a new data structure that allows us to look at our actors in a slightly different way, or a fairly different way, actually. And so that's often what you'll find, right? I want to speed up the question of X, okay? What data structure can I come up with that will allow me to answer that question very quickly? How do I maintain that data structure over time so that it's always correct? And by doing so, you dramatically speed yourself up, okay? So you'll find that happening all the time. I have some question I want to answer quickly. I'm going to invent a new data structure. My code will become more complex to keep that data structure valid as long as I need it, okay? Okay, this is also an interesting thing to think about. Be very careful about the data structures you add, because every data structure you add is another chance for bugs, okay? And you'd better get a good performance benefit out of that data structure, or it's not worth it. Okay, if it's only a tiny little performance benefit, cut that thing out, okay? Do it in the more naive way if it's going to simplify your code, reduce your bug chances, okay? Anyway, right, the question of can I move east, it's answerable in a grid world in O of 1 time. The data structures you need to maintain for that, not that crazy, okay? Not that crazy. A simple unordered map will do the job, okay? Mapping 2D grid cells to an integer, for instance. That's one approach you can take. And you can say the integer means like how many blocking actors are currently there. If it's larger than 0, you can't go there. If it is 0, or if it's somehow less than 0, then if it's less than 0, you've got a problem. Something has gone very wrong. Anyway, you can use that, and it's good stuff. You can update and maintain that data structure as actors move around, inserting yourself into the next cell, and that's O of 1 time, and it's going to scale probably pretty well, okay? Grids are not natural, though, right? This is not how we play games. This is not how the real world works, okay? This is not a grid, all right? Even though there are grid-like elements to certain parts of it, right? Super Mario, as we saw, not grid-based. Resident Evil, not grid-based, right? Though grids sometimes appear in modern games, if you want them to, they're useful sometimes, a fake grid, okay? Life without grids is a little bit spookier, okay? The grid is gone. Uh-oh. The question of can I move east? What is the answer? And to point something out, our bunny friend here has moved. The bunny is no longer at 1, 0. The bunny has moved slightly, okay, to 0.90. Riddle me this. Can we move east 1 unit? And it's like I'm getting nods yes, I'm getting some odd nods no, and it's like you can't quite decide, can you? Right? Because there's good rationale for either choice, okay? If you keep your algorithm the exact same and you continue to use that spatial map that we were using, mapping 2D coordinates to the number of blocking actors there, the answer is flat out yes. You can move there. Okay? You want to see it? Okay? Here we go. We can move it. Boom. There you go. See? I mean, look at it. Look at it. Right? Our goose is at coordinate 1, 0. It's the only actor at that coordinate. And our bunny is at 0.90. Okay? So clearly, we're fine, and this is great. This is a great outcome, right? They're technically not colliding. It's like, no, they look like they're colliding. This is a big problem, okay? They should be colliding right now if our game engine isn't totally broken. Okay, but the move to continuous worlds is just going to shatter your previous approach. Okay, it's just not going to work. All right, it's going to have horrible results. So we got to find something else. All right, we got to find something else. Okay, what kind of solutions just come to your head immediately? Yes.
Like rounding position to integer and then check the region.
Okay, we could do some rounding. Okay, so collision detection is now going to be based on what cell you're nearest to. All right, like that sounds interesting. Okay, maybe that'll work. I haven't. Yep.
I'll probably do like what I did for mono game, where you have to like get a vector between them and check that distance if it's like less somehow.
We can check how close our actors are to each other, and if they're within a certain distance, yeah, let's say that they're colliding. Okay? Now, wait a second. What happens if one actor is really big and the other is really small? Like, does that still make sense? Maybe. Maybe we could spice that up a little bit. Maybe in just a moment we'll talk about it. Yes?
If we don't, like if our actor doesn't really move very far away, I think we can just check in on window width by size and only check that particular window to see if there's any actors in those positions. So if our actors usually almost always in like the center, if you move the camera, we can just check like minus half like the width and like height and just check that one.
Okay, right. So we can do some kind of regional checks. Yep. Yes?
Oh, what I was going to say is maybe we can check the width of the sprite and kind of base that. Like what that's what their width is going to be. And then all the transformations to make sure if they're colliding or not.
Sure, we could use the apparent kind of visual size of these sprites and say, you know what, that's going to define some sort of collider size for us. Okay? Yeah, like all this makes sense, and they're interesting ideas. Here is a pretty basic one you could go with. You could say we're going to use the concept of a circle or a sphere collider. Okay? And this is basically saying we're going to define these shapes dedicated only to collisions. You don't see these shapes, actually. They're only dedicated to helping us detect if something is colliding. Okay? This is extremely common, actually, and not a bad idea at all. This is in Unity, and we have our actors here, our game objects, as we call them in Unity, And we've got the circle collider 2D component on both of them. You can actually customize these colliders. You can give them an offset from the location of the actor. You can give them a radius. You can give them a different radius. So this one might be smaller. This one might be bigger for the different character. Okay, and that can absolutely work. The parameters for such a thing are usually offset x, y, and the radius of the sphere. I suppose you could do an oval if you wanted to, though not in Unity with that. All right. If we wanted to do that here, then basically the algorithm is this. It's pretty darn simple. You can take the radius of both objects, okay, stack them up, right, add them, and if that is less than the distance between them, then no collision, right? However, if you move them really close, you can see that now our distance between the objects is smaller than their radius put together, and now we got a collision, okay? And that's like, yeah, that's pretty simple. It works. It's really fast. But spheres aren't the only option for us. We can get a little bit more control maybe if we go with something like a box collider, okay? And here you can see that. The green line around the squirrel is the box collider, and we can move that box collider around relative to the squirrel. We can change its width. We can change its height. That looks quite a lot better. It's probably going to look a bit better for our game, which is a game that's kind of using a 45-degree perspective on the ground, okay? So we put it around the characters, the bottom of the character image, and that creates a pretty good effect for us. And so it's a very, very common collision type. One interesting thing, and I'm not sure if I've talked about this yet, but so often you will find that game worlds look extremely detailed and luscious, right? The objects are very complex and seem to be full of polygons. But under the hood, in the world of physics, they're just extremely basic shapes, okay? For instance, Mario 64. This is a modded version of Super Mario 64 DS that has replaced the aesthetics of the world with the collision geometry of the world. So you can see the vague outline of a castle, but it doesn't have any of the detail, right? There are lots of boxes in this environment. There are as few polygons as possible, and there's just not much granularity, okay? Very often, we can get away with very simple physics, okay? Very simple geometry, physics geometry, that still is going to be kind of a good enough approximation of the visuals of the object. And it's going to save us a ton of computation, okay? This is a game that had to run on the Nintendo DS, a fairly cheap, underpowered handheld device from many years ago, before mobile processors started getting really good. And so this is how it had to be, okay? Physics and collisions are hard to calculate, and you need to simplify things as much as possible. The result was still fantastic. Did a great job, okay? Anyway, for a box collider, you can define one by the offset x and y away from the actor that the collider is associated with. You can also define an x and a y in terms of size, so width and a height, and that can get you interesting effects. One thing you might think about is you might want a really small collider to represent your characters that really fits the aesthetics well, so that the characters don't bump into each other and overlap too much. But you might want a gigantic collider for an invisible actor. What do you sometimes call that? You just got this big box in your environment. You put that box there, not to bump against necessarily, but yes, Raul? Trigger. You want to detect when the player walks through the trigger, so you can spawn the enemies in, and you can advance the stage and the plot that way. Okay? So, how can we detect these box collisions efficiently? Okay? There is an algorithm, and it's not too crazy. It's called the axis-aligned bounding box algorithm. Okay? And that's kind of a fancy name here. Axis-aligned. By axis-aligned, we mean that the axes of the volume, x and y, and maybe z, if you're in 3D, are aligned with each other. Okay? They're not skewed like this. This is not axis-aligned. You'll probably need slightly more fancy algorithm to deal with that case, okay? AABB pops up all the time, could very well make for an interview question that you might run into, okay? So the question then is, how do you compute? How do you compute this, okay? Imagine you're trying to algorithmically decide whether these two boxes are overlapping. Now your eyes can tell you right away that there is no problem here, okay? There's no overlap at all, right? Our brains work a little bit different than a single-threaded computer though, all right? And so, how can we start? Any ideas? And the way I like to start this is just a classic approach that makes everything way simpler. Anytime you have similar axes, you can very often, in like a physics problem, you can very often do what? Yeah.
Ignore half of them.
Yeah, you just choose one. And you're like, okay, can we disqualify our idea based on one set of axes instead of looking at both of them or all of them? So if this is too complicated, forget about 2D. Let's go 1D. Let's rock, okay? 1D collisions. Okay, let's go. We're going to consider the horizontal axis first, and then maybe later we'll consider the vertical one if we need to. All right? And now we have reduced our collision problem to horizontal only. Okay? We've got our box 1 right here, our box 2 right here. And maybe it's a little bit easier to kind of mathematically or algorithmically say whether these are colliding or not. We know they're not. Okay? You can tell that immediately. The key here is looking at something like this. Okay? For our box number 1, when we look at the x-axis, we should pretty easily be able to have and know what the maximum highest value of our box is on that axis. So the max, like the biggest value, the furthest along the number line. But if we say, oh my goodness, if x1 max, the max value on our x1 box, on our 1 box, is smaller than the minimum value on the 2 box, it's like there's no chance, right? There's no chance we could be colliding here, okay? And so we can start to build out an algorithm from this, right? If 1 box's max is smaller than the other box's min, there's no collision going on, okay? And in this case, it's pretty cool because we can exit immediately. We don't have to check anything else. We can just bail right away. Because notice here that if we're not overlapping at all on the horizontal axis, it doesn't really matter if we are on the vertical axis, right? Once we've blown one axis, there's no hope. The other one can match or not match. We don't care. We're just not going to overlap. It's not going to happen. So we can check one axis here, and then we can check the other. You can actually put this all into one and statement if you want to. But that's kind of it, okay? I've never been particularly good at geometrically picturing this kind of algorithm in my head. So I encourage you to kind of look at this and size these values up and convince yourself that this algorithm is going to work, okay? And I think that might help. And you might want to do that, just spend a minute or two trying it. It might show up on the quiz. Who knows? We'll see, okay? But the idea here is that we can relatively quickly, with a pretty simple algorithm, check if 2 boxes, for instance, SDL recs, which you're by now pretty familiar with, are colliding or not, okay? By the way, for the purpose of the homework assignment, if 2 boxes are sharing a border, like exactly, that's not considered colliding, okay? And so that's worth knowing. The spec should make that clear too. Okay, so colliders versus triggers, all right? We spoke a few moments ago that sometimes we want to just detect a collision happened. But imagine for a second that, Master Chief is driving through the map and we want this big collider there, invisible collider, and no actor to be seen. And then when we hit the collider, we want to spawn some enemies. And so Master Chief is driving at full speed, and the player hits the collider, and the car explodes. Because he just ran into a wall, basically. It's a collider, right? You collide. Boom, the player's dead. We spawn on the enemies, but there's no more player. It's kind of pointless. All right? So and 494 students have seen this already, but I want to ask a question. There's something wrong with this game, and I'm going to help you figure out what it is, okay? We're playing a rollerball game. I want to collect those right here, those spinning yellow blocks. I'm going to vocalize it for you to help you understand what's going wrong here. Okay, I'm going to grab that block. Ready? Ugh. Okay, all right, well, let's grab the next one. Ugh. All right, it's another coin. Jeez. Okay, wait, what's the problem here? Is that the way it's supposed to go? Collecting things is supposed to be so pleasant. Here, it's painful. What's the problem? What do we got? Yes?
It's a solid collider.
That's right. We're getting this physical collision here that we really don't want, okay? When it comes to collecting things in a game like this, we want to detect that a collision has occurred, but we don't want the physical ramifications of the collision. A collision without impact, okay? Sometimes we do want impact, but sometimes we want the collision without the impact. How can we make this determination, okay? How can we define what we want? If you look at this over here, Mario jumping against this block, this solid block, when Mario hits his head on the block, there's a physical collision here, right? Mario's acceleration comes to a standstill, and he starts descending immediately, okay? So over here, we have something called a trigger collision. They're both collisions, okay? But this is regarded as a trigger collision. In Unreal Engine, this is called an overlap collision, okay? In Unity and elsewhere, it's often called a trigger. And over here on the right, we have a physical, standard, traditional collision with impact and everything you expect, okay? And the difference in many cases here is whether or not a checkbox is clicked. In Unity, that's how it goes. You can convert any collider into a trigger collider just by checking a checkbox. Now, on your homework 6, you're going to have colliders and you're going to have triggers, okay? And you'll fill those out in a slightly different way. There's not just a checkbox here that flips them, because you can actually have actors that have triggers and colliders on them, and you have to deal with that. One interesting thing here is, for instance, you might have a character that has a collider, so you can't run into them. If you run into them, you're going to hit them, right? Or they might even strike you back. But that character's also going to have a trigger that's bigger around them. And that's the dialogue trigger. They start talking when you get within that trigger, but if you get too close, they whack you, okay? And that's for an example of an actor that can use both very effectively, okay? And again, here's what it looks like, right? On the right side, you got triggers. You go through the object, you collect it. There's a detection there, but there's no impact. Over on the left, there's impact and a collision. It's not the right choice. What's on the left is not right, okay? Not good. Okay, on the homework, you're going to use colliders for damage, okay? Damage detection and velocity change. You're right, so NPC runs into something physical, they get their position reset, and then they turn around and go the other way, right? And then triggers are mainly for dialogue, okay, on homework 6. Right, collisions, blah, blah, blah. Let's talk about some performance concerns. We got about 20 minutes left. And this is going to be a big deal. You might want to return to this, I'm guessing, as you work on homework 6, toward the end especially, okay? Yeah, we're going to have some test cases with 1 million plus actors. And I think the 1 million and first is like your player character. We're going to have at least hundreds of thousands of actors with collisions working on them. And this is going to be a pretty big thing, okay? I want to show you some data I collected while working on this assignment myself. Because I'll tell you, my initial staff solution for this 100,000 actor test case, I forget which one this is. This is definitely in Suite 6. Took me 91 seconds to calculate a single frame. Now, this is the naive algorithm. Okay, this is the naive algorithm where we're just going to iterate through every single actor in our actor list. And we're going to check each one of them. to see AABB if we're colliding with them. Okay? And that's every actor that does that and checks every other actor. Right? So what's the complexity of that? Yeah, that's disaster complexity, n squared, okay? Blow you up. All right. So after introducing a interesting optimization called the region system, we've gone from 90 seconds to half a second. Okay, that's better. That's a lot better, okay? And with no loss of accuracy at all. By the way, we're going to get this down by a factor we're going to get this down to about 0.1, okay? In just a little bit. I'll show you how, all right? All right, so some performance concerns you might have, right? AAB is already fast, but what can we do to speed this up, all right? Well, one thing you're going to need to ask yourself a lot on this homework, and I actually really like this part, there are just a lot of actors that you don't care about from a collision perspective, okay? If you've got an actor on it that doesn't have a collider and it doesn't have a trigger, it's like, does that actor even exist from a collision perspective? Not really. It's just kind of something you need to render. It might move, but it never collides with anything. Nothing ever collides with it. So you want to make sure you're not iterating over that actor. You want to keep the list of things you're checking as small as you can possibly get it. Okay? So you might ask, what actors even have collisions or triggers defined on them? One thing you can do is when you've got some code that is checking for collisions, you probably don't want to check the actors that have only triggers on them, right? Triggers are for like dialogue and stuff. You're not going to collide really with a trigger and reverse your direction. So you might want to try and separate your trigger-only actors from your collider actors, okay? And then some actors might not have either, and some actors might have both, okay? So you're probably going to find yourself introducing new data structures that try and make the separation and thus stay smaller, okay? Here's some performance data. I said we were getting 0.6, right? But when I separated the actors that have no collider or trigger from the actors with colliders, from the actors with only triggers, we went down, another 30%? 20 to 30% performance improvement right there. Not bad. We're headed lower and lower. By the way, how low do we have to get before we're at 60 frames per second?
60 milliseconds?
Yeah. So we're in a bit of trouble here, okay? Because this is half a second, and we need to get to 1/60th of a second to get to normal frame rates, okay? The staff solution ain't going to get there, but it's going to get closer, okay? So if you can get there, I'll be very impressed, and you should show us, and then we'll look through your GitHub, your GitLab, to see what you did, okay? Then maybe we'll take it for the staff solution. And then the homework might actually get harder for next semester. Ooh. Okay, no, we're not going to do that. We're not going to optimize too crazy much because that just makes it very, very nasty, okay? All right, you know what would be interesting if we had like staff solution, which is relatively optimized, and then we have like ultimate solution, right? Which has got every optimization we know of. That would be really interesting. Anyway, one thing you should ask, and this is a huge one, this accounts for most of the big performance improvement that we had in the staff solution. Can you find a way to check only the actors that are near us? Okay, I've got a question for you. Okay. All right. Ask yourself, are you colliding with anyone in this room? No. Okay, and when you made that decision, I saw you look around you, right? Okay. Who did you check to see if you're not touching anyone?
Wait, repeat that one more time.
So the question was, who are you colliding with? What other actors are you colliding with?
Nobody.
And you looked around to gauge that. Now, you could probably feel that probably not true. But you looked at who around you?
Like the people closest
Point
to
out
me.
literally the ones.
Yeah.
The people. Right? Boom, boom. You probably looked at me.
Yeah.
Okay? You looked at 3 people around you. You did not look at the other people around the room. You're pretty sure they're not touching you, right? Likewise, you're not thinking about all the humans in Ann Arbor, right? And you're not thinking about all the humans in the USA or the world. But the naive solution will literally be the equivalent of you thinking about every human in the world, okay? Maybe in the universe. And you're going to get a dramatic performance improvement if you can just make that, okay, I'm not going to think about every human in the universe. I'm only going to think about all the humans in Ann Arbor. That is a dramatic performance improvement, okay? That will bring you from 90 seconds per frame down to half a second per frame. If you can get that even smaller, you're going to get even more performance benefits, okay? And so there's a big question of, well, how do we do this, okay? What does near even mean, okay? Because I'll tell you this, what if there was a giant in Ann Arbor? What if there was a gigantic human being in Ann Arbor who literally, their thumb might be above the ceiling right now, okay? Maybe they're going to come in and they might actually be just about to touch you. You would have to check that Cyclops, right? And so you might find that what near means kind of changes based on the circumstances of your scene, all right? And the actors you know to be in it or not in it, okay? This could change in every scene that you load, okay? One interesting thing that you should keep in mind is that in this version of our engine, actors are not allowed to resize themselves. They're not allowed to move or change their colliders or triggers after they've been loaded into the scene, okay? And that is very powerful. It is yet another example of a moment where if we constrain our engine, if we put rules on it, we can get massive performance improvements, and we don't have to write super complicated code to get that, okay? And so if you want total expressiveness, if you want to be able to quickly change your collider sizes during the scene, like many game engines can, you're going to pay for that. You're going to pay for that in performance no matter what, but you're also going to pay for that with more complex code as well. That might be more bug-prone, that has to be more sophisticated, and so it's just a really interesting kind of philosophical thing. Anyway, I want to show you a really cool game. Has anyone heard of RimWorld?
You might think this colony humble. It was no simple undertaking. The 3 of us crashed landed here. Elena, a princess.
Manual labor is on becoming.
Greg, librarian. Good with books, not much else.
And what use is a washed-up soldier like you, Nelson?
Now we are survivors.
We built, mined, harvested,
Endured frightful conditions.
and hunting rabbits.
Beastly pirates raped us.
We captured some, recruited others,
We lived new lives.
entertained ourselves in time.
Greg and Elena married.
One must compromise one's standards here.
For company, we tamed turtles. But not everything could be tamed.
Greg started to drink.
You wouldn't stop cheating on me.
Others know how to treat a lady, Greg.
That was when Greg broke down and ran naked into a lake.
Yeah, well, let's not forget when Nelson hung out with his mama all day instead of building solar panels.
We all need downtime, Greg.
Despite everything, there was progress.
We began work on a ship to set us free. There will be no escape today. This is my base. This is my sanctuary.
This is my palace.
This is our colony.
All right, a lot of people really like this game. It's not hard to see why. It is a very busy game, lots of things going on, lots of units, big worlds, lots of resources, lots of pathfinding. There is a lot of computation that needs to be done in a game like this. And it has to be done very efficiently if you're going to have big maps, if you're going to have lots of units doing crazy things. It reminds me a bit of Dwarf Fortress in that way. This is a game, let me see here. Oh, come on. Oh, it's blocking my panels here. So this is a game with tons of complex units, a complex world, and good performance, actually. One question that the team had to deal with was, how do you search the environment quickly? Okay? How do you figure out, for instance, in pathfinding, whether a certain location is even reachable from a certain other location? How do you do that fast? A breadth-first search, if you've taken 492, not going to be fast enough. Okay? Let's take a really brief listen to this. This is a technical interview by one of the programmers on the game, explaining kind of how they sped up a bunch of stuff in their game to get better performance, which was a real problem before this.
So we've got all these problems, and to solve them, I have created what I'm calling the region system. So the fundamentals of the region system is a new set of data structures. You think about how you think about, how do you as a human being think about space in the real world? You probably, if I ask you, can you reach, from this room to this room in your house, you're not going to think about it in terms of 1 square meter steps on the floor. You're not going to think, okay, I can walk forward 1 step, and then I can walk forward 1 step, and then I can turn left 1 step, and then I can walk to the doorway 1 step, and this long series of operations, and then you eventually mentally arrive at your destination. Because, yeah, you're not going to do that. What you're going to think is, okay, I'm in the bedroom, then I can get into the hallway, and then I can get into the kitchen. And then that's only 3 operations, and you're there a lot quicker. But what you're really doing there is you're working through a different data structure at a higher level. You're not going step by step. You're going room by room. And so that is really what the game needed. That's what these guys needed, is a new data structure to look through. A new set of information that the algorithms could use. Once you got your data structured well, the algorithms are usually pretty obvious. So that new data structure is these regions right here. And so each region is a small area of the map. It's a set of cells that can each reach every other cell in the region with no restrictions. So there's nothing that could possibly block anybody from traveling within the region. Ditto for here, ditto for here. If you look, you'll see that, say I cut this in half, now it's 2 separate regions. There's one on the right, and there's one on the left.
Right, so this is region system, is basically the idea that we're going to not necessarily think in terms of cells, but we're going to group lots of cells together so that we can get a really fast feel for what is in this area, what is in this other area. And that sounds useful to me as far as knowing what actors should we check our collisions against, okay? Do we need to check our collisions against everyone in the city of Ann Arbor? Or if this room is a region, maybe we just check the people in this room, okay? So that is something that the staff solution uses, okay? We use a region system, which is a pretty natural upgrade from what you've been using on homework 3, 4, and 5, which is like a tile-based spatial map, okay? An unordered map, just simply pointing cell coordinates to a number of collisions in that coordinate. So if this is grid cells right here, right, and an actor can only be right on those cells perfectly, this isn't going to work for our continuous world in homework 6. But something similar might work, okay? Consider this then to be regions. And notice that our actors don't have to be in the direct center of those regions or directly on top of them, okay? Our regions might be ordered or named something like this. If you want to calculate what region you're currently in, basically what you can do is you can take the region size, do some division on your x-coordinate and your y-coordinate, and you can figure out where you are, okay? You can determine very quickly what region you're in terms of x and y, all right? A region is basically just a list of actors that are in that region. So if I want to say, well, I'm only going to check the actors in my current region, then you can, number one, take your actors' X and Y values, do some division to quickly figure out what region you're in, use that to check the data structure. Oh, I'm the only one in that region. I can ignore all the actors in here or over there, okay? And so it kind of accelerates and allows you to exclude actors. Now, there are some nuances here, okay? There are some nuances. What happens if your collider for your actor is over the line? You're actually in 2 regions, right? You could be in as many as 4 regions. With this region size and with this collider size, you could be in 4 at once. So you might have to check all those 4, okay? That's your collider right there. And you can say, well, what regions are the goose in? The goose is currently only in region 0, 0, okay? But if the goose moves over here just a bit, the goose might now be considered to be in 4 different regions, which means we need to check the actors in those regions, okay? And you can figure this out, basically, because we have box colliders, this isn't very hard. You can figure this out by just checking the vertices, the corners of each box. Okay, what regions are the corners in? Grab all those regions and then go check them, okay? You can use division to calculate. Here's a question. What happens if we have a very wide actor? What do? It's a little bit more awkward to figure out like what regions you're currently in, so you know to check them all, right? And in the staff solution, we kind of bypass this because I was writing the code for it and it felt kind of hacky. And so you know what we do to bypass it? We make the region size bigger, okay? So that basically we determine the region size by looking at all the actors in a scene and then kind of sizing them based on that. Now this will work for homework 6, but if things can change their size, that's not great. And performance does degrade if you have a really big actors, okay? Imagine one of your actors is literally the size of your entire in-game universe. This data structure is now not going to help you at all. So there are weaknesses here, but it was relatively easy to write and didn't mess with our code very much. The game designers probably aren't going to be super happy though, okay? When we tell them they can't do gigantic actors. Anyway, our region size can be chosen to make calculations easy and relatively fast, but you got to be careful. You can imagine a situation like this, okay, where our goose is not the only actor around. There are other actors around, and one question is, which actors should we actually check right now for the goose? Which ones actually? Any idea? You might be tempted to say, well, we should only check the rat, because the rat is the only actor in our region, okay? But it's potentially possible for other actors to be relatively close or to kind of be over a little bit. So in general, what you might want to consider doing is checking the region you're in, but also the surrounding ones, just in case. I recall I needed to do this, but I think I need to go look and make sure this is still necessary. Anyway, it's something that you'll want to look at as well, okay? You might want to check your current region for a given actor, and you might want to check the neighboring regions as well, okay? In other words, in this case, you get to check 2 actors for your collisions instead of 5, okay? And imagine being able to just check 2 other actors for your collisions rather than the million actors that might be there. That's going to save you a massive amount of time, okay? One thing to note is that the smaller the region size, the better, because the smaller the region size, the fewer actors are likely to be in there. You could still get into an awful case where all 1 million actors are literally at the same location, okay? And I'm not sure if I'm going to be able to help you with that. That's kind of an awful problem. I think a similar problem tends to occur when you are playing an MMO and you happen to have literally all the actors on your server partying in like one town square in one city, okay? Things get very dicey in that moment, and I remember crazy RuneScape parties where the server would start to buckle when too many people went to the same place. There are ways to deal with this, and there are interesting data structures, things like quad trees, which can be kind of flexible approaches. I looked at quad trees and I decided that it was probably slightly too much for this homework, which is already going to be a difficult homework, and probably a lot of you are already getting a bit tired. So this is approach that I think will be fairly natural. You're going to want to think about how to implement this and some of the nuances, because there may be bugs, especially if you size your region to be too small, and now you've got actors that can kind of lean over and contact each other, but your data structure can't realize that or recognize that, okay? And then one question you want to ask is, how small can we make a region without running into issues, okay? The improvement can be absolutely crazy. I think, like I showed you before, we went from 95 seconds to 0.63, okay? And with the other improvements added on, we were able to get to like 0.1, okay? So 1/10 of a second to calculate hundreds of thousands of collisions accurately. And so I hope you look forward to attempting some of these optimizations, okay? And let me know how it goes, all right? If you have other ideas on how you might optimize this, you're welcome to give those a shot too. Just because this is the approach that the staff took doesn't mean you can't do something better, all right? And so I look forward to seeing what you decide to do, okay? So good luck. It's 6 o'clock. I'll be around for another 2 hours here to help you try and get linking, try and get building if you need to, and answer any questions you might have, okay? We'll see you next time. See you Monday. Good luck. And remember, you got 24-hour extension on this homework 6, okay? We'll see you then.
So I saw my issue 4 minutes after the event.
What was it?
It was that I was using carrots around my includes instead of quotes.
A lot of people are using the carrots. And
It was
it's like,
a suggestion from someone to help me, and then I just left it in, and then it was causing me. But it's okay. But
in general, the carrots are like, they're used to say, search like the default system path, the default header repos on your system for X. Like standard libraries, you're probably almost certainly going to use the carrots. For anything you're bringing down or downloading yourself, or anything in your repo, stay away from the carrots. Like, they seem to also work differently on different platforms, I'm finding.
Oh.
So, yeah.
I had a quick question about a possible collision thing, which is like, could we kind of do like, we already know like their velocity, and so we could just like do raycasting basically and calculate exactly what frame they're going to collide on and like defer our calculations to like...
What happens if like okay, you do a raycast in one direction, but then another actor comes in and snipes you and blocks you at the last second from off screen?
I think you'd only need the first hit. You'd only need to recalculate when you've collided, right? So I think
this sounds like a research project to me. Like, I've got a novel collision detection algorithm here. We're gonna try it, and they're gonna live and die.
I don't think this will work, particularly because actors need to reverse their velocities.
Yeah.
That makes the entire thing more complicated.
Yeah. All right. Twitch stream. We'll see you later. Take care. Have fun. Good luck. GG. See you next time. Bye-bye.